Yes, hello, hi. Welcome back. Welcome back to EDUHUNT IIT Foundation classes. This is Sukumar, your chemistry mentor. Nana, in the previous class, we completed or we already discussed what is atomic mass or atomic weight or gram atomic mass, and we just entered into mole concept. But here, there is a big doubt. In that video, I told you several times, for you to by heart or memorize the element names, element symbols, then atomic numbers and mass numbers. I asked you to by heart memorize and work on that, right? I hope you do this, right? But the point is, whenever you approach that periodic table, okay, while studying that mass numbers, you came across some fractional mass numbers, and many students will get doubt there. Why the atomic mass is fractional, sir? And so many students are asking me that also. Why the atomic mass is fractional, sir? Yes, the question is reasonable. How? See, for suppose I told you, for suppose there is a chlorine atom. There is a chlorine atom. In the periodic table, this is the symbol for the chlorine atom is Cl only, okay, and the subscript, that means atomic number is 17, mass number is 35.5. Now definitely student will get the doubt, sir, why the atomic mass is fractional? Why the atomic mass is fractional? Now, this can be our heading also. Okay, today's topic discussion is, in the periodic table, why the atomic mass is fractional? The question arises, see, why it can't be fractional first of all? Yes, normally it can't be fractional. Why? Because atomic mass, this is mass number. Mass number is different from atomic mass. The point is, this is, I told you already, this is the number of protons plus neutrons, right? Number of protons plus number of neutrons. See, proton number can be 1 or 2 or 3 or 4 or 30 or 35 or 36 or 37. But 35.5, it can't be fractional. There is no half proton, there is no half neutron, or there is no 3/4 of a proton. Not like that, na? Proton number is 30 or 35 or 36 or 37, that only. Or neutron number is also like that only. 17 proton, 17 neutron. 17 proton, 17 neutron, 34 mass number. Or 17 proton, neutron number is 18, 35. 17 proton, neutron number is 20, 37 total. So that is possible. But half proton, 3/4 proton, 1/4 neutron. So fractional is not possible. Na? The point is, in nature, I told you, atom is neutral. Atom is neutral because number of protons in the nucleus is equal to number of electrons. But neutron is a chargeless particle. Neutron number can vary a little bit. But the point is, see, in nature, naturally, I'm writing here, in naturally occurring chlorine, for suppose this is the container having, this is the container having some chlorine, okay, naturally available chlorine, okay. But in this chlorine, all atoms are not same type. How, sir? See, chlorine, atomic number 17, mass number 35. this type of chlorine is available in nature. Along with this type, there is one more type of chlorine atom also available. Mass number, atomic number 17, mass number 37 also. Sir, how it possible, sir? Yes, I told you. For the atom to call or for the atom to identify as a atom of particular element, what is important? Proton number is important. I told you in the previous video, if the number of protons in the nucleus is 6, then it's carbon, no problem. No matter what is the number of electrons, no matter what is the number of neutrons. If the number of protons in the nucleus is 6, that is carbon only. Like that, if the number of protons in the nucleus is 17, that is chlorine only. You can add electron, you can remove electron, still chlorine atom. Neutron number can be 1 or 2, plus 1 or minus 2. Neutron number can vary a little bit, no problem. Until unless the proton number is 17, this is chlorine only. So that's why we are having chlorine atoms, two types of chlorine atoms, but with different mass number. Then how? Proton number is same, then why the mass number is changing? Because the change in the neutron number. And I told you already how to calculate the neutron number also. How? Neutron number is equal to mass number. You remember or not? Neutron number is equal to mass number minus atomic number, right? Yes. Now try to count the neutron number here. Number of neutrons here is 35 minus 17. 35 minus 17. That means here 17 protons and 18 neutrons. So number of neutrons is equal to 18 here. And in that atom, that is also chlorine atom. That is also chlorine atom. But number of neutrons is different. N dash. N dash is equal to mass number is 37. 37 minus 17. 37 minus, that means 37 is the protons plus neutrons. 17 is the protons. So you are subtracting protons from protons plus neutrons. That means number of neutrons is 20. 37 minus 17, you got 20. So neutron number is different. That's why for the same element of chlorine in nature, two types of atoms are available. Like this for chlorine, two types. For other elements, there can be more types. Like hydrogen has 3 types of atoms available. Okay, hydrogen is an element, but that element atoms are 3 types. Okay, so when we have this kind of different types of atoms for the same element, these are called isotopes. Isotopes. Now, if you want to define what is isotope, isotope is atoms having same atomic number but different mass number. Okay, atoms having same atomic number, different mass number are called isotopes. So simply, isotopes are the atoms of the same element but different mass. Why the mass is different? Because of the difference in the neutrons. This is the idea. So like this, every element, that means there are so many elements in the periodic table which exist as isotopes. Now the question arises, in the nature, if you got some amount of chlorine, if you brought some amount of chlorine, there is a question, how much percentage is this one and how much percentage is that one? That means if I take 100 atoms, of chlorine, in that 100 atoms, how many atoms of this type and how many atoms of that type? Okay, that is called the percentage of abundance. So that is the practically studied value. You have to take the naturally available chlorine and took that chlorine to the laboratory, and you have to do some experimental studies to find out what percentage of chlorine is this type and what percentage of chlorine is that type. For suppose, in the practical data is telling you chlorine has almost 75% of C35 isotope, and rest of the 25% is C37, not C30, Cl37. So if you take 100 chlorine atoms, the practically determined value is telling you, if you take 100 chlorine atoms, in that 100 chlorine atoms, 75 atoms are of this type and rest of the 25 atoms are of that type. Okay, but both are chlorine only. But isotopes of chlorine, two types of chlorine. Okay, isotopes. Now there is a name for this percentage called isotopic abundance. Isotopic abundance. What is isotopic abundance? Isotopic abundance is the percentage of a particular isotope of an element. Isotopic abundance is the percentage of a particular isotope of an element. Okay, both are the different atoms of the same element. Fine. I hope you understand this. Now, if I ask you a important question, what is the atomic mass of chlorine? Now the question, what is the atomic mass of chlorine? If I ask you the question, then what's your answer? By just looking at this atom, you will say 35. No, in nature that is also available. Or just looking at that atom, you will say 37. No, in nature this is also available. When I say chlorine, both are available, na? So only telling the mass of this or that is not good, na? Not correct. So what you have to do, if I ask you the mass of the chlorine atom, you have to take the mass of the average. You have to take the average mass of the both kinds of atoms. Okay, so that is called average atomic mass. Okay, let us say MAVG. What it means is average atomic mass. This means average atomic mass. How to calculate? Just simple percentage. The percentage 75 into mass 35 plus 25 into mass 37 by 100. First, it's very simple percentage calculation. For suppose in your classroom there is 100 students. In your classroom there is 100 students. Okay, imagine. In that 100, 75 people got 30 marks. Okay, and 25 people got 90 marks. Then what is the average marks? Average marks 75 into 30 marks plus 25 into 90 marks by 100 students, total students, right? Yes, that is the way we need to calculate the average atomic mass. So what percentage is having this much mass? 75%. So 75% into 35 mass plus 25% into 37 mass. 25% into 37 mass, and total is 100. Okay, and that gives you this 35.5 average atomic mass. That's why the atomic mass is fractional in the periodic table. I told you to memorize. Memorization is a very beautiful, important cognitive function. It is the great ability of human beings. Don't underestimating memorizing power. Our Indian education system largely focuses on that memorizing ability. You do that. First understand the concept. Then memorize all the facts and the concepts in the proper order. So there is a periodic table available to you. In that periodic table there is around 119 elements. You have to memorize the names, symbols, atomic numbers and mass numbers of at least 1 to 30 elements. While you are doing that, you will came across certain fractional values, and at that time you may get the doubt why the atomic mass is fractional. That's why I made this video. Atomic mass is fractional because this is the average atomic mass of the isotopes of that particular element. Okay, I hope you understand this. Thank you.